All right. Hello. Welcome back. We are getting into the last topic in ACT science. Not the last topic with me because we got to do math yet, but this is the end of ACT science, or nearing the end. We'll have 3 or 4 days on this. Last thing is conflicting viewpoints. The good news about these is that I'm not going to give you as many of them because you're not going to end up seeing as many of them. It's probably good news because those research summaries, I gave you a lot of those. Why? Because you're going to see a lot of those. So you need more practice on those. But conflicting viewpoints, we'll give you we'll ease off the gas just a hair, and we'll talk about this last type of science passage. Each ACT science test contains one and only one conflicting viewpoints passage. Only going to have one of these. In this passage type, either multiple theories or hypotheses are presented, or multiple scientists disagree on a topic. There's some clearly conflict, right? People, they don't agree, right? People with competing explanations for something. That's how you write conflict in math, or inconsistency rather. It used to be the case that just 2 points of view tend to be explored. It's often 3 or 4 viewpoints are going to be more common. So we're going to have 3 or 4 opinions on how something happened, or explanations of phenomena, or descriptions of a theory, or something along those lines. Don't care about much of the rest of that. Conflicting viewpoints tend to follow a very definite structure. They're kind of the same. They do kind of the same thing every time. There's an intro that's relevant to all points of view. The intro is the stuff that everyone agrees on. Introduction, everyone agrees, great. Then different points of view, each one separated by an italicized header. Often that's going to look like, maybe student 1, 2, 3, or scientist 1, 2, 3, something along those lines. Great. These things are gnarly, completely different. They don't look like the rest of the science test, really. So much that you should always save it for last. And I think that's pretty good advice. The one caveat I'll say is if you're the reading superstar, if you're like above a 29 in reading, 28, 29, you're up, you're trying to get big money, then maybe you tackle this one in order. But gosh, it offers the potential to be a massive time suck. Can be a time suck. It can just you end up spending 10 minutes on this thing, and that could have been 10 minutes you used pointing out stuff on a graph because you're good at graphs. Right? Graphs, we can find things on graphs. We can do that. We can make sure we're looking at the right figure. We can make sure we're looking at the right variable, and we can go to the number. We can do that. Sometimes reading is harder, especially when you don't know what the heck any of it is talking about. It can appear anywhere on the test. If it's the very first passage, maybe you do it. Save it for last, unless it's like the first passage, because what do you usually see on the first passage? Pretty easy. I'm gonna put a little caveat: unless first or very good at reading. It says unless it's the first passage or you're very good at reading. If that's you. If it's not you, you're saving it for last. Treat it like a reading passage. It talks about reading through the text. We're not going to read through the text. We're going to treat this dang thing like a word search. Quite frankly, we're gonna treat it like a word search. You don't need to memorize facts. Where is it here? Is it talk about? We'll get to it. All right. As with research summaries, you don't need to memorize facts. It's open book. Few questions you need to be able to answer. What is known and indisputable? That is what's in the intro, because people don't disagree on what's in the intro. It's the common ground on which they all stand. So if you're asked to go back to the intro, or what do they all agree on, that's nice. Major differences. We've encountered a few words that tend to signify major differences. Except, instead, however. Yeah. We got some. We've run across these sorts of words. Say, okay, everything's the same except this one thing, or we did everything like we did the first time, but instead of peanut butter, we put cat food on it. I don't know. Are there any similarities? You know, words that signify they're the same. What was common procedure? Common to both or all? And why do the scientists disagree? Ooh, that one's hard. That one's hard. Those are the hardest questions of the test. Those, if you're trying to get those right, you're trying to get like above 30. I'm going to suggest for most of us that the why questions, those are the hard ones. Those are the ones we can end up skipping if we're crunched for time. Because I want you guys to spend 2 minutes working on 2 separate data questions rather than 2 minutes working on a hard reading question that you might end up guessing on in the end anyway. So the why do they disagree, that goes to rationale. And that's hard. That's hard. I'm sure I misspelled rationale there. So you're not going to read through this. You're going to word search it. The maxim is that the questions in the conflicting viewpoints are always easier than the passage, and that's true. It's often going to be a word search type of thing. You don't have to fully grasp what they're talking about, because I don't sometimes fully grasp what they're talking about because I'm not trained in every field of science, right? We recommend that you give students several. Yeah, okay, so we're going to give you a bunch of these. All right, so I'm going to work through the first one with you. You're going to get a timed second one, and there's a third passage in here, which is your homework. There are only 3 passages to do today. You're going to notice for all these conflicting viewpoint days here on out, there is just one passage, or one packet rather, not one passage. And it'll all get submitted to a single kind of practice homework assignment. So kind of next few days, easing off a little bit in terms of raw number of passages you're doing. So let's jump into it. We're looking at this thing, and how do you know it's a conflicting viewpoint? Well, there's no graphs, no graphs, tables, it's no data, got nothing. So that's how I know this thing's a conflicting viewpoint. What are some things I notice about the passage? I notice up here is my intro, and here are my 1, 2, 3. These are the competing hypotheses. So we've got our introduction, which everybody agrees on, our competing hypotheses. You might notice that those 3 hypotheses have very similar formatting. They're gonna talk about things in the same order, right? So I'll leave that in your mind, then we'll see it play out here. So I'm gonna just jump right into questions. I'm not gonna spend a lot of time digging through this. I might read the intro. Okay, got monarch butterflies migrate to Mexico. They overwinter. That sounds like fun. In high altitude forests, they accumulate lipids, fat, use a source of energy. Okay, and we got some hypotheses pertaining to when the butterflies store lipids and when the energy from stored lipids is used. Okay, so if you read anything, you might ask, what the heck are these people going to be talking about? That's going to be in the intro. Don't spend a lot of time reading anything else. You're not going to remember all of it, and you're not going to know enough to like say, oh, that's right. You don't know anything about butterflies, unless you do. That'd be weird. Which hypothesis, if any, asserts that monarch butterflies store lipids during 2 distinct periods? I am quite literally going to search for the phrase store lipids in each of the hypotheses. Just going to look for them. 2 distinct periods. All right, monarch butterflies require energy from stored lipids for migration and during the overwintering. Okay, stored lipids for migration, but not during overwintering. Stored lipids. Stored lipids during the overwintering, but not migration. Which one of these talks about to? The one with the and. Do I know what any of that means? No. I mean, I do, but you know, it's when are they packing on the weight? When are they eating extra whatevers? So we're going to hypothesis one there. Nectar. I don't know what they eat. I don't know anything about butterflies. Keep on moving. Which hypothesis, if any, asserts? You know what that word asserts even means? Just says, claims, that monarch butterflies require energy from stored lipids neither for migration nor overwintering. This is an easy, relatively easy conflicting viewpoints because it's got a few questions that say, oh, well, you just looked this thing up. Here's a related thing to the thing you just looked up. Okay, well, we just saw the and, we just saw the but not, and we saw the but not, but we didn't say a neither nor. We didn't see any neithers. Since we didn't see any neithers or nors, that's going to be none of these. You might have searched for neither nor in relation to those stored lipids. Excuse me. Keep on moving. Let's go pink. Number 10. Oh, it's telling us where to look finally. That's exciting. Some of these are going to tell you where to look. That's nice. Based on hypothesis 3, which of the following figures best depicts, shows, you know what that word depicts means? Illustrates. I'm going to write that real word illustrates. See, if you didn't know what that word depicts means, that's hard, right? Which of the following figures best depicts the change in lipid mass from the beginning of migration to the end of migration? Okay, hypothesis 3, change in lipid mass. So I think I'm looking kind of for change in lipid mass. I'm going to search for that. And if I look for hypothesis 3, all right, oh, lipid mass. Ooh, what does it do? Continuously increases. Folks, you don't have to know what anything is. That sounds weird. You don't have to know what's going on with these butterflies. But if you can find the phrase that seems to be the trend they're talking about, the important science term in the question, can you find that important science term? And then can you say, oh, lipid mass, what does it do? It goes up. All right, you can do this. Answer there, J. So let's keep going. Green. Number 11. Assume, it's going to be harder. Assume that changes in the body mass of a monarch butterfly are caused by changes in the mass of the stored lipids. Okay, so what's that saying? You know, we're not, the butterflies aren't putting on muscle. All they've got is this lipid energy source, and they're either filling up the lipid tank or they're emptying out the lipid tank, and they don't have any other way of gaining or losing weight. Great. The statement, oh God, the percent of a monarch butterfly's mass that is made up by lipids, okay, lipids, is greater at the beginning than at the end, is supported by which hypothesis? So if it's greater at the beginning than at the end, we're talking about what? We're talking about a decrease. So you need to go back and look at lipid masses and say, who talks about a decrease over the course of migration, greater at the beginning than at the end? Draw yourself a picture. Do you know what that looks like? Can you visualize that? If you can't draw a picture for it, then it's hard to come up with synonyms that you might be looking for in the text. So who talks about lipid mass decreasing during migration? Okay, during migration, oh great. During migration, lipid mass continuously decreases. Okay, that's 1, so that's good. During migration, lipid mass decreases, that's 2. 3 says, oh, increases, so that's a no on 3, but 1 and 2, there we go. Cool. So we can, it's a word search. Like, what seems to be important? Lipid mass, migration, going down. That's what it's asking about. And so much of what we're doing in here is trying to turn what is ultimately a very wordy question into something hopefully a little simpler that's easier to spot the answer to. Let's keep going. Number 12, to store lipids, monarch butterflies convert sugar from nectar they've consumed into lipids. Great. A supporter of which hypothesis, so that's our question, is going to be which hypothesis, if any, would be likely to claim, okay, that to ensure butterflies can store lipids for the overwintering period, nectar must be present at the overwintering site. So who talks about storing lipids at the overwintering period? And I would go ahead and search for that, look for overwintering, look for store lipids, and you might notice, hope I have someone knocking at my door. All right, sorry about that. The COVID czar came for a visit. Isn't the time of COVID fun? Just having a great time. Okay, store lipids for the overwintering period is where we were. Get my mind back in the place. You might notice overwintering. Oh, they must store lipids again. Oh, fantastic. Oh, so nice. All right. Store lipids is not required during overwintering. Do not store lipids at the overwintering sites. It is, gosh, it is the word search. It is just a word search. So hopefully you figured out store lipids again at overwintering. That is number 1. Excuse me. 2 to go? Nice. Let's go to maroon. Number 13, which of the following statements about lipids in monarch butterflies is consistent with all 3 hypotheses? All right. Okay, so we have lipid masses do not change, lipid masses change, use energy from stored lipids during overwintering, use energy from stored lipids during migration. Okay, so I kind of look like I have some like pairs of answers talking about either lipid mass or the use of energy. Does everybody use energy in the same place? No, if you've been paying attention, you found that some use energy for migration, some overwintering. Okay, this says not overwintering, this says not migration. So they don't agree. So they don't all say one or the other. So you can cross out C or D. I think that's the easier pair to cross out. If you didn't remember that, then you just have to go back and look. But hopefully you've held enough in your head from the previous question to say, oh yeah, well, some said this, some said that. They don't agree on that. That's not the thing they agree on. But what do they all agree on? They have sources of energy somewhere, right? And if they all agree that lipid mass is what? At some point, it's decreasing or it's increasing. Decrease and increasing. What is decreasing and increasing? That is changing. Nobody says they don't change, not A. Answer there is B. The order in which you knocked those out, I think you would probably knocked out either, I might have knocked out A first and then knocked out the CD pair, but that's a hard question. The last 2 are the hard questions, and the 14 is even a prior knowledge question. There's nothing in the text that helps you answer 14. When the monarch butterflies use their stored lipids, the lipid must be broken down to produce energy-rich molecules that can be readily used in cells. Which of the following molecules is produced as direct result of the breakdown of lipids? You just have to know this. I mean, you have to know that lipids, those are fats, and fats ain't starch, fats ain't DNA, fats ain't amino acids. ATP, adenosine triphosphate, do you remember that from someone in Bio 1 who mentioned it to you once? I don't know. Those last 2 questions are hard. There's no quick way to answer 13 unless you like really understand the text. These are hard. So let's keep working. We got another one here. You might notice one aside here. In every previous packet I've given you, all the questions are from the same test. I gave you the 2 data reps from that 04 test, or the 3 research summaries from the B04 test, whatever. But with conflicting viewpoints, right, they're all from separate tests. So I've written the 3 tests they come from if you're ever trying to find keys on Crack ACT. One more, well, two more for you to do. One more that I'm going to show you how to do. Passage here looks like it's about some chemistry. That's exciting. Pause the video. Set yourself a 5-minute timer. You're not going to be able to do it all in 5 minutes probably, but that's when you're going to start this passage. Unless it's at the very beginning of the test, you might do it. Give yourself 6-minute timer for this one. 6-minute timer. Start. Pause the video. Thanks for pausing. All right, so let's spend a few minutes going over this passage. I'm going to work it for you. So let's get into it. A teacher asked each of 4 students to describe the molecular shape of arsenic trifluoride. Great. Arsenic trichloride, arsenic tribromide, and arsenic triiodide. Arsenic trihalogen compound. Great. Don't care. Not really. Number 1. The table below gives the atomic mass of the elements F, Cl, Br, and I. Great. Based on student 4's description, among the elements listed in the table, as atomic mass increases, what does atomic radius do? Okay, atomic mass, increase, F, Cl, Br, I. Student 4. Atomic size, from smallest to largest, F, Cl, Br, I. Oh, those are in the same order. As atomic mass goes up, atomic size goes up. A, increases only. Boom. Easy. They're in the same order. Number 2, which of the students claimed that the AS atom in the ASF3 molecule has a lone pair? That's an easy word search term. All you had to do was look for the word lone pair back in each of the students. Student 1, student 1, student 1. The AS atom has a lone pair. 1's in. If you know that 1 is in, you can immediately cross out G and J. So now the question would be, you want to save yourself some time. Once you assess 2, you'll know the answer, because it's either 1 and 2 or 1, 3, and 4. There's no mystical third options here. So look at 2. The AS atom does not have a lone pair. So it's not 2. I don't even have to look at the other options. I know it's going to be option H. You can go back and look, and you will see indeed has a lone pair. Lone pair, right? But you didn't have to look at those. You could have verified it positively, or you could have answered the question more quickly via the negative, by eliminating answers. And that's the thing in here. A lot of times we can speed this up if we say, well, that's the only answers left. Okay. Number 3, which of the students would be likely to agree with the statement, all 4 atoms lie in the same plane? I'm gonna probably search for that. Lie in the same plane. All the atoms lie in the same plane. All the atoms lie in the same plane. So 1's in, 2's in. 3, all the atoms do not lie in the same. Ooh, 3's out. So 1 and 2, if you look at your answer options, we don't have to check 4. It's 1 and 2 only. You might have checked 4, but that would have been a waste of your time. Looking at the answer options ahead of time can tell you what work do you need to check. Sorry. Number 4. Consider the following. Consider the claim that there are 3 unique bond angles in an ASF3 molecule. This claim is consistent with the descriptions of what students? Consistent, recall, agree, aligns with, matches up with, whatever. Okay. 3 unique bond angles. Boy, if you search for unique bond angles, you will find the answer. 2 unique angles. Only 1 unique angle, so it's not 1 or 2. Go back. You can cross out those options. Number 3, Okay. Oh, only one unique bond angle up there on number 3. All right, so 3's out. If 3's out, everybody's out. Cool. Sorry, gotta pause this. Sorry about that. Okay. 3 more to go. Almost there. Based on the descriptions given by students 1 and 2 and 3, which of the students would be likely to agree that the sum, add them up, of the 3 bond angles in an ASI 3 molecule is equal to 360? So, you know, X plus Y plus Z equals 360. Well, let's look. All right. Look at your answer options, 1, 2, or 3, so I don't need to consider 4. Equals 360. Okay, well, 180 plus 90 plus 90. All right, that works. That's 360. All right, 120 plus 120 plus 120. Yeah, that's 360. Yeah, that works. 109, 109, 109. 109 times, oh no, 109 times 3, 327, stinky face. All right, so it's not student 3, it's gonna be 1 and 2 only, judging by that picture there. A, not B, not C, not D. Cool. Sorry. Number 6, a molecule of ammonia has only one unique bond angle. Bond angle is 107. The N atom also has a lone pair that strongly repels the 3 NH bonds. Based on descriptions by students 2 and 3, is the molecular shape more likely trigonal planar or trigonal pyramidal? And you notice I've got planar student 2, planar student 3, pyramidal student 2, pyramidal student 3. Don't spend a lot of time reading those answer options. They are the same thing over and over. Is it planar or pyramidal? Is it 2 or is it 3? I see 107 and I see lone pair. Those are like the 2 phrases that look sciencey. Then you might have the repels the NH bonds. I think that will also actually work to get you the answer here. So I say, what did I say? 107. Down here, student 2 is 120. Student 3 is 109. 107 is close to 109. That's 107-ish. Notice talks about lone pairs. Talks about repelling each other. And it says trigonal pyramidal. I mean, just looking through, which one has the words? 3, pyramidal, done. 3, pyramidal. Answer option J there. Last one, the data in table 1 are most consistent with the description given by which student? Where is table 1? Table 1's right here. After the 4 descriptions were offered, the teacher used the computer program that determined that in each of the 4 molecules there is only one unique bond angle and calculated those angles. Who got it right? Who talked about one unique bond angle? Who seems to have got this right? So it's not student 1. Could be student 2. Could be student 3. Could be student 4. All right, so that didn't help us that much. The data in table 1 are most consistent with the data description given by which student? All right. So the bond angle changes. The bond angle depends on the size of the atom that's, oh, it's student 4. Is there a quick way to get that? No, not really. You just got to be able to dive through this pretty quickly. Could have crossed out 1 pretty easy. I think you could have crossed out 2 pretty easily as well, and you would have been looking at 3 or 4. In judging between 3 or 4, you said this is always 109. This seemed to suggest there's some size dependency. Is there a quicker way than that? No, that's the hard question, folks. I don't have a quicker way for you. That's the end of conflicting viewpoints 1. You've got one more passage to do, talking about when do the wood mice come out to visit. You're a wood mouse. You don't like to be eaten. When do you go out and visit? Okay, you do that one. Scan it all in. There's one place to scan it on Schoology, and that will be the end of your conflicting viewpoints introduction. See you next time for conflicting viewpoints practice and group work number 1.